Hey, what's up guys? I'm Alan from Alan's Inventions, and on today's video I will be showing you guys how I pretty much just made this battery powered Raspberry Pi camera using Motion EyeOS, a couple of 18650 batteries, and packaged it all together in this 3D printed case. So if you guys want to see a step-by-step video on how I made this, make sure to watch the rest of this. For step one, I recommend you set up your Raspberry Pi Zero to make sure that it's working and configured with the camera, just to make sure that you don't put it all together and then you have to take it apart. So head over to the Motion iOS website, all links down below. Download the right firmware for the Pi that you are using. This will only work for the Pi Zero W, at least the 3D printed case, but you can see there's other options for different microcontroller boards. Next, head on over to Balena Etcher, or to download a copy of that. This is going to be the software that's going to flash the image from Motion iOS that you just downloaded onto your SD card. And I prefer to use this one. You can use, Win32 Disk Imager or any other program, but for me, I prefer to use this one. Again, link down below. Now, while the software downloads and after I flash it to the SD card, one thing I did do is I switched out the sensor that comes with the Pi camera module. I replaced it with an 8 megapixel sensor, so this should give me a 4K resolution video output. As you can see here, the sensor just fits the same connector, and it has a little bit of double-sided tape on the bottom, so it looks like it came stock from the factory. Now that your SD card is nice and ready, you want to slide that in there into the slot, of course, like it's the DMs, and hook up your USB to Ethernet adapter. Make sure to hook it up to the USB port, not the power port, otherwise it's not going to work. Next, take your camera module. You'll need a 15 to 22 pin ribbon adapter, cable thing, whatever, that you'll pull out these little tabs. Make sure not to break them, because if they break, the ribbon cable is just going to slip out and it's going to make the whole thing just harder to assemble later on. You'll see what I'm talking about later. So anyways, plug this into the Pi Zero. Then after you have it all hooked up, you're going to want to plug in your power and make sure that it's working. This will only be required for the initial setup. Like I said, I'd recommend that you guys sort of pre-configure your Raspberry Pi before installing it into the enclosure, just so that you can have access to the ports. You're going to want to find out what the IP address is from your router. There's different routers, so I won't go into detail about that, but usually just log into your router or find an IP scanner, run it on your computer, and get the IP address for the camera. It'll be something like my eye or something like that. The default password and login is admin. So after you type in the IP address, you'll be greeted by the login screen. And from here, you can go through the settings and start to configure it, at least to connect via Wi-Fi. That's the most important part. Make sure that you're on the same Wi-Fi as you are on now, or on the same Ethernet connection that you are on now as your computer, so you can get back into it. After some initial configuration, it was time to continue the build. So step one for me was to assemble the 18650 battery pack. These batteries are very common. You can salvage them from old laptops. I've used them in my other projects, so feel free to take a look around. These are rated for between 21 and 2400 milliamp hours, depending which ones you buy or which ones you salvage. And there's devices that you can use to test the battery capacity. I actually have a screenshot here of me testing these batteries to make sure they were equal. You want to make sure that the batteries are charged to equal voltages, because once you solder them together, they will level out. So if one's at 4.2 volts and one's at 3.7 volts, they're going to want to equalize. And because these are high discharge capacity batteries, that transfer of energy is going to happen really fast, and you're going to have a lot of heat or sparks or some other fire hazard that's not really necessary. So be careful. These are still dangerous batteries, but if you know how to handle them, more power to you. All right, time for a break. I know you're loving my puns, but if you guys could please drop a like down below or a comment or something just for the YouTube algorithm, I would really appreciate it. As you can see by all this footage, making these videos is hard, and I spend a bunch of time and good comedy content that you can't buy anywhere else on YouTube to make these. So all I'm asking for is a like, subscribe, maybe hit the bell. Thank you. And then back to our regularly scheduled programming. By now, you should have known to start the 3D print when you started watching this video, so it should be done by now. Just kidding, it's not. It takes like 4 to 5 hours. I use an Ender 3, printed it flat side down like this, use supports, 20% infill. You can check out the Thingiverse link down below. It'll have all the files that you need. But once you have it, your batteries drop right into the enclosure, and then you have to make sure that you push it all in all the way to the bottom. One of the batteries does fit in a little bit tighter than the other. Slide in your TP4056 module. Wait for it. I know you guys really like my hot glue gun because it's pink. So here it is again. Don't get too excited. Contain yourselves. Then just add some hot glue to the bottom of the enclosure, and you're going to stick your charging module onto that. If you use my prints exactly as they are, you'll also have this nice little stand that will level out the mount I included in the 3D print, so everything sits flat while you're working on it. Next up, it was time to hook it up to the Raspberry Pi, and here I recorded a time lapse of me attaching the blue wire and the black wire from the TP4056 module to pins number 4 and 6 of the Raspberry Pi. Pin 4 is for 5 volts, pin 6 is for ground, but then it hit me. How am I supposed to turn this thing off? Now here in this video I am showing you guys footage from the future because I haven't attached the Raspberry Pi yet, but essentially what I did was I cut the blue wire and wired a switch in between. So if you ever have to know, cut the blue wire. I hooked up a switch to it, and then that goes directly in between the blue wire. No need for any other connections, and it just keeps it really simple. This is your on-off switch. This basically cuts the power from the Raspberry Pi to the battery pack. Next up, I then used some double-sided tape and stuck the Raspberry Pi to the roof of the lid, slid the cable in through the slot, slide the ribbon cable in, click in the adapters, and you're good to go. This is a little bit out of order here. You don't see the switch, but once you wire the switch in line with the blue wire, the switch just goes inside. I didn't put a slot on the outside of the camera to turn it on or off, so if you do want to turn it on or off, you'll have to take off the blue lid and flip the switch, and then you just mount the camera to the 4 mounting holes outside. You undo the connection clips for the ribbon cable, and then just slide the cable right in. And I just want to emphasize, be really careful with these clips, guys, because I broke 2 of them. Once you break them once, they're never the same again. So once it slides right in, then you just kind of tuck the rest of the cable in there. And then finally, for your last part, you take your last 3D printed part and it just slides right over. This does click into place. There's 2 alignment pins in there. As soon as you get everything fitted right, it should just snap and you're good to go. There you go. You have a fully battery powered Raspberry Pi W0 camera. I added this slot down at the bottom. I took my old camera mount from my Ecamm that broke. I took the threading, or I'm sorry, the thread or thread nut, whatever, off of it. You put it into the hole. I don't know if you can buy these, but then I took my soldering iron and just heated it up, and it should, I know it did. I already saw this. I saw that too. Anyways, slide your mounting nut, it's hot, be careful, into the camera. Play popcorn with it, hot potato, whatever. Once it's cool enough to pick up and your camera doesn't focus, it doesn't for the rest of the video, you put this thing on there and you hope it does, but it doesn't. So it'll slide right in. Then your camera will focus. And then you're done. You can attach a little mini tripod to this and set it up wherever you want. I did some power estimates, and it was really hard because it depends on how much you use the camera, how much motion there is. But I would say on average I get about 2 to 3 hours with about 20 to 30 minutes of activity within that hour to activate the camera, because it is set on motion detect. So there's a whole lot of variables and things that I could get into about battery life and this and that. And you know what, I could even hook up this little 5-watt solar panel that I use in the thumbnail. I could set it up outside. It's not waterproof, that's in the plans, but for now it's a proof of concept. I designed the case. I want to get some bulkhead mounts for it, for the sides, show off the SD card slot and things like that. But I hope you guys enjoyed this video, and I will see you in the next one. If you're still watching at this point, I just want to say thanks. I really appreciate it. Thank you guys, and I'll see you in the next one.